Right now, beneath the surface of every ocean on Earth, a system of invisible rivers is quietly deciding whether London gets winter snow or year-round frost, whether the Amazon rainforest survives the next century, and whether 600 million people living in coastal zones wake up to a radically different world. And the terrifying part? Scientists say part of this system may already be failing. Fact number 1. The ocean conveyor belt moves 100 times more water than every river on Earth, combined. The system we're talking about has a scientific name: thermohaline circulation. Thermo for temperature, haline for salt. Together, these two forces drive a global loop of ocean water that researchers at the Woods Hole Oceanographic Institution describe as Earth's circulatory system. Now here's the number that should stop you cold. This conveyor belt transports approximately 20 million cubic meters of water every single second through the Atlantic section alone. That's a flow rate roughly 100 times greater than the combined discharge of every river on the planet Earth. The Amazon River, the Nile, the Mississippi, the Congo, all of them flowing simultaneously, still wouldn't come close. And this colossal movement of water doesn't just sit there looking impressive. It redistributes heat energy from the tropics all the way to the poles, essentially acting as a planetary-scale central heating system. Without it, the average temperature in Western Europe would drop by an estimated 5 to 10 degrees Celsius, not over centuries, but potentially within decades. Visual note: animate a color-coded world map showing current flow arrows in blue and red, with a bar chart comparing ocean conveyor volume to combined river discharge. Fact number 2. There's a current moving so fast underwater it would tear a ship apart. Most people picture ocean currents as slow, lazy drifts. But in 1977, oceanographers studying the Strait of Gibraltar discovered something extraordinary. The Mediterranean Sea loses more water through evaporation than it receives from rain, making its water saltier and denser than the Atlantic. That density difference creates a phenomenon called the Mediterranean outflow, a deep underwater current that exits through the Strait of Gibraltar at speeds reaching 1.5 to 2 meters per second, roughly equivalent to a fast-running river. But here's the jaw-dropping detail: as this dense salty water plunges into the Atlantic and descends to depths of around 1,000 meters, it generates underwater turbulence with eddies, called MEDDIES, Mediterranean eddies, that are 100 kilometers wide and can persist for up to 2 years as they drift across the Atlantic Ocean. These spinning underwater lenses of salty water carry their distinct chemical signature thousands of kilometers from their birthplace. Scientists can track them like fingerprints in the deep ocean. The energy in a single MEDDIE is estimated to be equivalent to roughly 100 atomic bombs. And this is just one small tributary feeding into the global system. Visual note: display a cross-section diagram of the Strait of Gibraltar showing salinity gradient layers in contrasting colors, with an animated MEDDIE swirl chart. Fact number 3. The Gulf Stream keeps Europe 10 degrees warmer, and it almost stopped during the last ice age. Here's the fact that climate scientists genuinely lose sleep over. The Gulf Stream, the most famous component of the Atlantic conveyor, transports warm tropical water northward along the eastern coast of North America and across to Europe, releasing an estimated 1.3 petawatts of heat into the atmosphere. To put that in perspective, that is roughly 100 times the total electricity generating capacity of the entire United States. This heat release is the primary reason that London, sitting at the same latitude as Calgary, Canada, has mild winters while Calgary regularly hits minus 20 degrees Celsius. Now here's where history gets terrifying. Around 12,900 years ago, a catastrophic flood of fresh meltwater from the retreating Laurentide ice sheet poured into the North Atlantic. This freshwater surge, known as the Younger Dryas event, is believed to have dramatically weakened or temporarily halted the Atlantic circulation. The result? Global temperatures dropped by as much as 10 degrees Celsius in some regions within just a decade, not a century, a decade, and stayed there for approximately 1,200 years. Pollen records, ice cores from Greenland, and deep-sea sediment samples all corroborate this catastrophic climate flip. And the mechanism that triggered it back then, fresh cold water diluting the salty dense water that drives the conveyor, is the exact same mechanism scientists are watching nervously today as Greenland's ice sheet melts. Visual note: show a Greenland ice core timeline infographic with temperature anomaly lines and a color gradient map of North Atlantic salinity changes. Fact number 4. Scientists found evidence the Atlantic current is now at its weakest point in 1,600 years. In 2021, a landmark study published in the journal Nature Geoscience, led by researchers at the Potsdam Institute for Climate Impact Research, analyzed sea surface temperature and salinity proxy records, including sediment cores and coral records, stretching back 1,600 years. Their conclusion was stark: the Atlantic Meridional Overturning Circulation, known as AMOC, the system that includes the Gulf Stream, is now circulating at its slowest pace in at least 16 centuries. The weakening accelerated significantly after 1950 and has lost an estimated 15% of its strength compared to pre-industrial levels. A separate 2023 study published in Nature Communications went even further, suggesting that based on statistical modeling of sea surface temperature patterns, AMOC could be approaching a critical tipping point, potentially collapsing sometime between 2025 and 2095, though the precise timing remains uncertain and scientifically debated. What is not debated is the direction of the trend. The current is slowing. The question scientists are urgently trying to answer is not whether, but how fast and how far. Visual note: animate a time series line graph from 400 CE to 2024 showing AMOC flow strength, with a sharp red decline marked after 1950. Fact number 5. A current beneath Antarctica drives climate in places it has never touched. Most people have heard of the Gulf Stream. Almost nobody talks about Antarctic bottom water, and that is a serious oversight. Formed around the coast of Antarctica, particularly in the Weddell Sea and the Ross Sea, this water is the coldest, densest water in all of the world's oceans. At temperatures as low as -1.9 degrees Celsius, just above the freezing point of salt water, it sinks to the absolute bottom of the ocean floor and spreads northward along the seafloor into the Atlantic, Pacific, and Indian Oceans. Here's the staggering implication: Antarctic bottom water essentially ventilates the deep ocean. It carries oxygen, nutrients, and absorbed carbon dioxide from the surface down to depths of 4,000 to 5,000 meters, sustaining ecosystems that have never seen sunlight. Without this deep ventilation, the bottom of the ocean would become anoxic, oxygen-free, wiping out the vast majority of deep-sea life. A 2023 study published in Nature Climate Change by scientists at the University of New South Wales found that Antarctic bottom water formation has already slowed by approximately 30% since the 1990s, driven by accelerating Antarctic ice sheet melt. That single statistic has the deep ocean science community deeply alarmed. Visual note: use a 3D ocean depth cross-section infographic showing Antarctic bottom water as a dark blue layer spreading along the ocean floor northward across hemispheres. Fact number 6. There is a place in the Atlantic Ocean where water sinks like an elevator, and it drives climate across the entire planet. In the North Atlantic, just south of Greenland and Iceland, exists one of the most critically important, and visually unremarkable, patches of ocean on Earth. It looks like any other cold gray sea. But here, in a region oceanographers call the North Atlantic Deep Water Formation Zones, something astonishing happens. Surface water, having given up its heat to the atmosphere and warmed Europe in the process, becomes dense enough to literally sink. Not slowly drift downward, sink, at a rate of up to 1 centimeter per second, plunging thousands of meters to the ocean floor in what oceanographers describe as convective chimneys, vertical columns of sinking water sometimes only 10 to 50 kilometers wide. This sinking is the engine that pulls the entire conveyor belt forward. Without it, warm tropical water stops flowing north, the heat engine stalls, and everything downstream changes. Researchers deploying Argo floats, robotic ocean profilers that drift and dive autonomously, have documented these chimneys directly. There are only a handful of locations on Earth where this deep water formation occurs: the North Atlantic, the Labrador Sea, the Weddell Sea, and the Ross Sea. These 4 small regions essentially control the ventilation of the entire global deep ocean. Visual note: display a color-coded diagram of convective chimney columns in the North Atlantic with depth scale markers and Argo float trajectory overlays. Fact number 7. The Pacific Ocean has a current so enormous it has its own name, and it regulates global rainfall patterns. The El Niño, a southern oscillation, universally abbreviated as ENSO, is not just a weather pattern. It is the single most powerful year-to-year climate fluctuation on Earth, and it is driven entirely by changes in Pacific Ocean surface currents and sea surface temperatures. Here's how dramatic its reach is. During a strong El Niño event, like the record-breaking 1997 to 1998 event, sea surface temperatures in the central and eastern Pacific warm by 2 to 3 degrees Celsius above average. That temperature anomaly, covering an area larger than the continental United States, disrupts the Walker circulation, the atmospheric engine connecting the Pacific and Indian Oceans, and triggers a chain of consequences that reshapes rainfall and drought patterns across 6 continents simultaneously. The 1997 to 1998 El Niño caused catastrophic flooding in Peru and Ecuador, simultaneous severe drought in Indonesia, Australia, India, and southern Africa, and contributed to wildfires that burned approximately 25 million acres of forest across Southeast Asia. Total estimated economic damage exceeded $45 billion. And the 2023 to 2024 El Niño event was documented by NOAA as one of the 5 strongest on record. Scientists project that as ocean warming accelerates, extreme El Niño events, the kind that cause the most severe global disruption, could occur twice as frequently by 2100. Visual note: animate a split-screen Pacific Ocean temperature anomaly map comparing neutral year versus El Niño year, with color-coded regional impact icons showing flood and drought zones. Fact number 8: if the ocean conveyor belt fully collapsed, the results would be catastrophic and irreversible for centuries. This is where all 7 previous facts converge into the most important one. In 2004, a major report commissioned by the U.S. Department of Defense, not an environmental group, the Pentagon, concluded that an AMOC collapse represented a greater long-term threat to global security than terrorism. Here's what the science says would actually happen. A full AMOC collapse would reduce average temperatures in Western Europe by 5 to 10 degrees Celsius within a matter of decades. Simultaneously, and this is the counterintuitive part that stuns most people, it would accelerate warming in the southern hemisphere and the tropics, because heat that currently gets pulled north by the conveyor would accumulate instead near the equator. Monsoon systems in Asia and Africa, which feed approximately 3 billion people, would shift dramatically in timing and location. Sea levels along the eastern coast of North America, particularly around New York City and Boston, would rise by an additional 0.5 to 1 meter above global averages because AMOC's current flow actually suppresses sea levels there by pulling water away from the coast. And here is the most chilling scientific reality: once AMOC crosses its tipping point, it does not gradually recover. Climate models consistently show that re-establishing the conveyor after a collapse would require hundreds to thousands of years, even if greenhouse gas emissions were halted immediately. It is a one-way door. A 2022 paper in Nature Climate Change estimated the annual global economic cost of an AMOC collapse at up to $11 trillion per year by 2100, more than the combined GDP of every nation in Africa, South America, and Australia combined. The ocean has been silently regulating this planet's climate for millions of years. Right now, in 2025, for the first time in human history, we have both the science to understand that system in detail and the measurable evidence that we are destabilizing it. Visual note: display a multi-panel infographic. Panel 1 shows a European temperature change map. Panel 2 shows a monsoon shift diagram. Panel 3 shows a U.S. East Coast sea level rise projection chart. Panel 4 shows an AMOC recovery timeline bar graph spanning 1,000 years. The ocean doesn't ask for your attention. It doesn't send alerts or push notifications. It just keeps moving, or it doesn't. And when it doesn't, everything changes. Subscribe to Moonlit Minds for daily mind-blowing facts that will change how you see the world.